Over this measured 12-metre section, the winch pulls the same crate with the same cable force. Both runs are steady, but the second run takes half as long as the first. Has the second winch done more work? No, the work is unchanged. The power has doubled, but the same energy transfer has taken place, but in half the time. In physics, work is energy transferred by a force through displacement. For a constant force, work done equals force multiplied by displacement multiplied by cosine theta, and theta is the angle between that force and the displacement. The cable pulls with 50 newtons at 60 degrees above horizontal, and the crate moves 12 meters horizontally. Work done is 50 multiplied by 12 multiplied by cosine 60, which is 300 joules. The cosine is important. It selects the signed component along the displacement. In this case, there is no vertical displacement, so the perpendicular component does no work. The formula always refers to a particular force. Weight and the normal contact force are perpendicular to this motion, so each does zero work. Friction points the opposite direction to the displacement, so the work done by friction on the crate is negative. Work done against friction normally means its positive magnitude. If force changes with displacement, there is no single value to substitute. Work is the signed area under the force displacement graph. On a different run, suppose the force acts along the track and rises uniformly from 0 to 40 newtons over 12 meters. The triangular area is 1/2 multiplied by 12 multiplied by 40, i.e. 240 joules. Area below the axis is negative work. Return to the original pull. The cable does 300 joules of work on both runs, over 6 seconds. The average power is 50 watts. But over 3 seconds, the average power is 100 watts. Power is work done divided by time. 1 watt is 1 joule per second. The same work in half the time requires twice the power. For a constant force along the motion, start with work done equals force multiplied by displacement, then divide by the time taken. Over an interval, displacement divided by time is average velocity, so average power equals force multiplied by average velocity. At any instant, power equals force multiplied by the instantaneous velocity. For an angled force, retain cosine theta. The faster run is steady at 4 meters per second. 50 multiplied by 4 multiplied by cosine 60 again gives 100 watts. The same relationship appears in top speed problems. A car travels at constant 30 meters per second against 600 newtons of resistance. Constant velocity means zero resultant force, so the driving force is also 600 newtons. The useful power, therefore, is 600 multiplied by 30, or 18 kilowatts. Mass is not needed because the resistance is given and the acceleration is zero. The engine still does positive work. The resistance does equal negative work, so the resultant power is zero even though both forces transfer energy. Now return to the winch during the 3-second run. Its meters show 125 watts of electrical input power and 100 watts of useful mechanical output power. Efficiency is the useful output power divided by the total input power. 100 divided by 125 is 0.80, or 80%. The remaining power is 25 watts. Energy is therefore transferred to the internal energy and sound at a rate of 25 joules each second. The same ratio works with energies instead of powers, provided both quantities refer to the same process. An answer above 100% means the fraction has been inverted or inconsistent quantities have been compared. So work measures how much energy a force transfers, power measures how quickly it transfers it, and efficiency measures the useful fraction. In the next lesson, we will follow every joule through the system using the principle of conservation of energy.